Hi, today we're going to take a look at how to find the area of a loop. I got bored, so let's go and take a look here. Now I know this is going to be a loop because the smallest, it's the biggest it will ever be is 3. So if it's a negative 3, such that when cosine is pi, it's telling me my radius is going to be negative 1, which means we're going backwards. And that's how we form the loop on limicons. So if I have my function right here, r, theta r, if I want to graph this, 0, pi over 2, pi, 3 pi over 2, and 2 pi. If I plug in 0, I'm going to get 2 plus 3, which is 5. If I plug in pi over 2, I'm going to get 2 plus 0, which is just 2. And here's what my loop becomes. 2 minus 3, so minus 3 because cosine of pi. I get negative 1. That's my loop. We'll talk about that in just a moment. 3 pi over 2, I get 2 plus 0, which is 2. And if I plug in 2 pi, it's going to put me back to 5, where I started from. So if I were to sketch this, right here, starting at 0, if I'm facing 0, I go out 5 units. Facing pi over 2, I go up 2 units. Now, when I hit pi, it says to go back 1. So, I'll get to that in just a second. At 3 pi over 2, so I'm facing 3 pi over 2, I go down 2. And then I'm back to 5. So when I'm graphing this, what happens here is I'm going to go around, and what happens is I'm going to go over to the third quadrant. Don't go backwards. I have to go through the first quadrant, second quadrant. It's going to go through the pole. Now, why do I know it goes through the pole? Because take a look. Between pi over 2 and pi, right? Between the second quadrant, between pi over 2 and pi, my value goes from positive 2 to negative 1. At some point, we must cross 0. That's the intermediate value theorem. So I know it crosses 0 in the second quadrant. It's going to make my loop, and it's going to hit 0 again, because again, in the third quadrant, between pi and 3 pi over 2, I go from a negative to a positive. It has to cross 0. And there's my graph. What I want to find is this area of the loop. So let's talk about the loop. Well, what forms the loop? You may recall, well, the loop starts when the radius is 0. So it starts when r equals 0. So that's what I have to find, when the radius is 0. So I'm going to go 2 plus 3 cosine of theta equals 0. And I'm going to get cosine of theta equals negative 2/3. Now, I have to use a calculator for this, okay, because we don't know those values. So, now most times the answers are much nicer for us. So, I'm going to go second cosine, trig, inverse cosine of negative 2 divided by 3. I hit enter, and it's going to give me theta equals 2.3. Now, that's the first time it reaches in the second quadrant. So it's theta equals 2.3. Now, where's the second time it's going to cross? Where it ends, right? So theta equals, so how do I get the second time? Well, I'm just going to add pi over 2 to that. So if I add 2 pi over 2, because that's how we get the in the next quadrant. So I take that 2.3 and I add pi over 2. Let's see here, pi divided by 2. I hit enter, and I get 3.87. So, and that's where it ends, at theta equals 3.87. So it starts here in the second quadrant and ends at theta is 3.87 in the third quadrant. So second quadrant, and it ends in the third quadrant. How do we know that? We got that from here. In the second quadrant, we know it crossed 0, and in the third quadrant, we know it crossed 0. So my equation to get the area is 1/2 from 2.3 to 3.87. And I'm just going to type in my equation, 2 plus 3 cosine theta squared d theta. And that will give me the area of the loop. So the next question people always ask is, well, how can I get the area of the area outside of the loop? Well, we'll talk about that on another time, okay? That's a little bit trickier to do, but think if you can think about how to do that. I will give you a hint, though. When you measure the area, if you go all the way around, like from 0 to 2 pi, you're actually going to count that area twice. So you just got to kind of subtract some things there. But there's a couple of easier ways to do that one. All right? So I'll see y'all later. Bye-bye.